Hello dear students, here we will start our next lecture on basics of signal. So here you can see that on the basics of signal, first of all we have to know that what is the signal. Signal is a function of one or more variables that conveys information about some usually physical phenomenon. For a function, that means it is an attribute of time, it is an attribute of some variables. It can be sample, it can be time. If it is time, so it is a continuous, and if it is samples, so it will be discrete value. Apologies. So a signal is a function of one or more variables that conveys information about some usually physical phenomenon. For a function f in the expression, each of the signal, that means the t1, t2, tk after tk, is called an independent variable, while the function value itself is referred to as a dependent variable. Some examples of signals include a voltage or current in an electronic circuit, the position, velocity, acceleration of an object, a force or torque in a mechanical system, flow rate of a liquid or gas in a chemical process, a digital image, digital video or digital audio, a stock market index. They all are known as a signal. So why these attributes came forward? Because a voltage and current are dependent on time, so it's a function of time, so it can be known as a signal. Then we go through to the classification of signals. Signal, we have a lot of classifications in terms of some attributes. So first attribute is the number of independent variables, that means dimensionality. A signal with one independent variable is said to be one dimensional, that means audio. A signal with more than one independent variable is said to be multidimensional. It can be image, it can be video, it can be like that, 3D image or 3D video, all of this. So that is dependent on several variables. One dimensional variable is audio because it depends on time and the amplitude of the amplitude and frequency, and also frequency of your voice signal. And the signal which has one or more independent variables like image, that means it has two axes, that x-axis, y-axis, and both have the pixels there, so that will be multidimensional. And if it has the another time domain included into it, so it could be a video. And continuous or discrete independent variables. A signal with continuous independent variables is said to be continuous time, CT, that is voltage waveform. A signal with discrete independent variables is said to be discrete time, that means stock market index, it has discrete variables. And continuous or discrete dependent variables, a signal with a continuous dependent variable is said to be continuous valued, and if it is discrete dependent, so it can be discrete value, known as digital image. So a continuous valued CT signal is continuous time signal is said to be analog signal, it means voltage waveform. And a discrete valued digital time signal is said to be digital, that means digital audio. So now you can see that the continuous time, that has no breakage or any kind of interval between between the points of the graph and the plot. There is no gap on it or interval, but there are a gap on the DT or discrete time signal. So so that's the factor, that is the graphical representation of the both signals. Now you can see that there are some properties of signal, that means even signal, odd signal. There are the classifications, periodic signal, and a lot of other properties are being taught here. So now you can see that what are even signals. Even signals, as a function x is said to be even if it is satisfied xt is equal to x minus t. That means whatever has been given negative to the time function, that has not been considered, that should have to be positive always. And if that is considered as sequence, that you can see here xn is equal to x minus n for all n, so it is even to be satisfied this. So whenever a even signal, the function, the even function that really constitutes the even function, that means that really depends on the even function, so that is even signal, or the property is quite similar to the even function. So geometrically, you can see there are two graphs have been drawn or have been added here in the slide, that you can see that there are the two distinguished signals. First signal is the continuous time signal. You can see here there is one kind of reflection or mirror or symmetry between the two axes, because in the axis of you can see the xt axis between y axis, like as you can see, if you just pause this line as a mirror, so you can see that it follows like that, that a mirror has been set down here. So that's why I have told you that that is an even signal, and that is one of the property to understand the even signal graphically. uh, Now you can see the discrete time, that is in the same situation, that the two parts are quite equal in that situation. That means in the matter of y axis. And the completely different part is the odd signal. Whenever you have given the uh, t, that means the time, that means reflection, that means minus t, you give the minus t or minus n, you get the total value as minus. That means the amplitude also go through to the minus. And the most probable function of odd signal is like that, that is the sine signal. Whenever whatever else, if you give the negative angle onto the sine function, you will definitely get the total negative sine function with the positive angle t, because sine minus t is equal to minus t. So that is an odd signal that you can see here. So geometrically, the graph of an odd signal is antisymmetric about the origin. That means if it is antisymmetric about the origin, that means it is symmetrical between the x-axis. You can see here, if you just draw a line, if you just think over a line between the x-axis and understand the fact, you can usually see that that is one kind of a mirror of it. If it is a positive sign, that will be the negative sign. If it is a negative sign, that will be the positive sign. So just like anti-symmetrical or symmetrical around the x-axis, here is also the same, that you can get the 3, that is 1, and it's minus 3 is minus 1. That means quite anti-symmetrical in that part. So these are the properties of the signal. There are some other properties and other classification of the signal, that is periodic signal. As you know, that whenever a particle runs through and get onto the same point again, that makes a period. So these kind of periods, if a signal just draw the same kind of attentions between these signals, that are the periodic signal. That means it should have to be governed by this law, that is xt is equal to xt plus capital T. The capital T is the period. That means if you add the period, you will get the previous value. So a function x is said to be periodic or with period t is if for some strictly positive real constant, the following condition just holds that. So in that situation, 1 by t is the frequency, and angular frequency twice pi by t. And similarly, if you give the period of the what can I say, that is the discrete time signal, that's n plus capital N, you will definitely get that same thing, that is the periodic. And the signals which doesn't have this kind of property, after if it doesn't satisfy this condition, that are known as aperiodic signal. So you can see here, that is a clear cut solution of the periodic signal. There you can see the sequence has been same throughout time to time, that has been same throughout time to time, so same interval -4 to -1. That means after four samples, they have get the same type of trending out of that. So in analog signal, the trending is like that, is just the same thing, that a simple minus t or minus t by 2t, so they get the same thing. So that is the periodic signal. So there are some periodic signal are here too, that you can see here, that is if you give just make a double of it, that will be strictly logical to that too. So there is no problem here. So that's all for now to the factor of the signals. Thank you very much for being with me.